Alright guys, we are halfway there going through this unit review. We're on number 10 now. This page with the dude pushing the box. Number 10, I'm going to look at the diagram before I even read the problem. And I'm going to try to guess what it's going to ask me and think about what I already know. So when I look at this diagram, I see someone pushing a box, an arrow in the direction of their push showing the force of their push. What I don't see labeled is the force that's working against, right? About equal and opposite reactions, the force that's working against that push. Whether it's a stronger force, an equal force, or a weaker force, I don't see that on the diagram. And so I'm going to assume they're probably going to ask me that. So when you think about pushing a box across the surface, your push is going to be affected by whatever you're pushing that box on. If I'm trying to slide that box across tile, my box is going to move much easier than if I was trying to move it, say, down a driveway or on carpet. So I'm assuming that this question is going to have something to do with friction. Let's check. So we have a worker shown in an illustration pushing a box with a force shown by the arrow, but the box does not move. What keeps the box from moving even though the worker is pushing on it? So I have to think, okay, well, there must be a balanced force happening here. What is the name of that force that works against things as they move across each other? Probably know what I'm talking about. So F says the worker is pushing the box in the wrong direction. Well, that has nothing to do with whether a box is going to move or not, so we're going to skip that one and move on. There's too much air resistance for the box to move. Well, when we think of air resistance, think of things like parachutes and drag racing. Is that really what's happening here? I don't think so. H says the force of gravity opposes the force exerted by the worker. Well, that statement's just not true. Gravity is working down. The worker is pushing across. Those motions are not opposite. They are not opposing each other. So it can't be H. Hopefully I works. Let's see. I says the force of friction opposes the force exerted by the worker. Now I know friction is that force we were talking about that works in opposition of things moving across the surface. So the only logical answer choice here is going to be I. Let's look at 11. 11, we have a table. And anytime I see a table, I want to look at the table and just ask myself, what do I know? What can I figure out based on this table without anybody guiding me? We want to get really, really good at reading tables because then those aren't going away either. So I have blocks of different colors. They have different masses, but I'm noticing everything else is the same. So we have these different color-coded blocks that all have different masses, but the force to push them and the amount of friction they're working against is consistent. They're all being pushed with a force of 24 newtons, and the friction, the force working against that push, is a force of 6 newtons for all of them. So the one thing that they're changing in this experiment is the mass, and they're only color-coding the blocks to tell the difference, to know which one is which mass. I look at this table and I immediately see that the one with the least amount of mass is going to be the blue one, and the greatest is going to be the green one. I know the green one with the greatest mass is going to move the least distance or have the less change in motion because of its larger mass. It's going to require more force, and it's not getting any more force. It's getting the same treatment as everyone else. The blue one, being the one with the least amount of mass, is most likely going to move the farthest. So now I need to look at my answer choices in the question and see if I'm on the right track. The question is, which block will have the greatest change in motion? So I've already analyzed this table, and I've already figured that out for myself. Now I just have to find the answer that matches. We know the one with the greatest change in motion is going to have the least mass. If I look at my choices, I know that's blue, which on here is going to be B. Okay. All right, top of the next page, we have a diagram that looks like this. We have, let's see if I can pull it back into the light. There we go. So a force of 20 newtons acting upon this block from the top. So we can assume that that's the force of gravity. And then we have 60 newtons acting upon the force of this block on either side. Now I know opposite forces can either be balanced or unbalanced, and they can cancel each other out or they can cause a change of motion. The 60 on either side, since they're equal, are going to be a balanced force. We need to read the problem though to see what is it that they want us to figure out from this diagram. So the problem states the following illustration shows the forces that are acting upon the box. What type of motion will the forces cause? So when we look at this one, will the box remain in its current position? Well, we know that the 60 and 60 are going to cancel out, but there's still a 20 Newton force acting upon the top of this box. And there's no arrow to indicate that there's a force opposing it from the bottom. So it can't be F. It's not going to stay still because not all of the forces are balanced. Then we look at G. Please excuse my whiny dog. He sees a cat outside. The box will move downward in a straight line. Now this one could be a contender. We know it's not going to move side to side because the balances are forces. Yeah, the forces are balanced. However, it could move down due to that 20 Newton force with nothing opposing it. We can eliminate H because we already said it's not going to move to the right, and we can eliminate I because it's not going to go back and forth, which only leaves us with G. The box will move downward in a straight line.